Welcome to Laplace Transforms Lecture 3. So if we could please pause the video and please try these two revision questions for me just now. Okay, answers. Number 1. So remember, we're going to our Laplace Transforms table on page number 18 of the Laplace Transforms booklet. So first thing we notice, we have an exponential multiplying something else with a t in it. So it's an exponential in t multiplying a second function in t. So that means it's a first shift theorem, right? So I want to Laplace transform f of t, which means I want to Laplace transform e to the power of 5t cos 3t. Right, now as we said last week, a Laplace transform becomes capital F S, right? Now, because, as I've said, it's an exponential in t multiplying another function we can Laplace transform, it becomes square brackets, it's first shift theorem, right? As S becomes S take away whatever the number is in front of the t in the exponential. And as I said to you before, you need to try and find a way of making your s's and your 5's look slightly different. Right, so then I look and see, right, what's the Laplace transform of cos 3t? Well, the book tells me it's s over s squared plus a squared, and my a is 3, so it's s squared plus 3 squared. S goes to s take away 5. Right, now, what we have here is, we then need to sort out this. Now, all this is saying, wherever you see an s in your Laplace transform, you swap that for s take away 5. That's s take away 5 all over s take away 5 squared plus 9. And there's my Laplace transform finished. Okay, question number 2. Right, so I want to find, well, f of t, that's 6t e to the power of negative 2t sin 6t. Right, now, that there is just a number coefficient, right? So it's a constant coefficient of everything else. Now, remember, if we find the Laplace transform, that 6 isn't involved. Right, it's just a constant multiplying it. Right, so what I'm interested in Laplace transforming is t multiplied by e to the power of negative 2t sin 6t. Right, now same thing again. I see you've got an exponential multiplying other things with a t in it. So it tells me that's the first shift theorem, right? So that means that f of s equals, and first shift theorem means I swap the L and this stuff for a big square bracket, like that. And I say s is going to s take away whatever that number is there. So that's s going to s plus 2. Okay, because s take away negative 2 is s plus 2, right? Now I just imagine this exponential is not there because I've dealt with it by creating my first shift theorem here. So I go to my formula sheet, or my Laplace transform sheet, And I can see I've got one for t multiplied by sine something t. Now I've got t sine 6t. So all I'm going to do is swap 6 in place of all my a's in my Laplace transform. Right. So that's 2 multiplied by 6 multiplied by s all over 6 squared, sorry, a squared plus 6 squared squared. Right, so that means that fs is equal to 6 12s over a squared plus 36 squared, as s becomes s plus 2. Now all that, I'll just get rid of that. All that bit there means is wherever you see s, you're going to swap that s for s plus 2. So f of s equals 6. And do this bit first, that's 6, just leave till the very end. That's 12, s plus 2. You remember all your s's are becoming s plus 2. Like that. I suppose that just becomes a normal bracket rather than a square bracket because we've done our first shift theorem. Right, so then we just multiply the 6 and the top of the fraction together. So that just gives me 72 s plus 2 over s plus 2 squared plus 36 squared. And if you want, you can multiply out all the brackets and stuff like that, but I'm pretty happy with that as a final solution because you've done the full Laplace transform. If you want to make it, if you want to multiply the bracket there, multiply the bracket there, then you can, but I wouldn't. Okay, so that is finding the Laplace transform. So the last thing we did last time was just a little introduction to inverse Laplace transforms. Now we're going to go and do it properly. Right, now, as I said last time, this involves partial fractions, completing the square, and a whole lot of different things from previous maths courses, so your past knowledge is going to have to be quite good. Okay, so inverse Laplace transforms. So no obvious inverse transform, i.e. you can't just look at the table and see, right, oh, that looks like that, so that's obviously the inverse transform, right? One, factorise the bottom of our fraction and use partial fractions. 2, complete the square and use inverse first shift theorem, or a combination of 1 and 2. So sometimes we've just got to factorise and use partial fractions. Sometimes we've got to complete the square and use first shift theorem, or sometimes we've got to factorise and use partial fractions and complete the square and use inverse first shift theorem. Now the combination of the two doesn't come up very often, but it can happen. Right, now that's the order I want you to look for it in. 1, see if you can factorise and use partial fractions. If you can't factorise, then look to see if you can complete the square, and then after you've completed the square, sometimes you might also have to use partial fractions. Right. Right, so type 1a, right, and that is when you can factorise, remember that CDT, common factor difference of two squares trinomial. For this, it'll either be difference of two squares or trinomial mostly, but you can see common factor. I'll show you examples of each one. The bottom of the fraction and you do not have a repeated linear factor. That just means repeated bracket, right? So you don't have the same bracket twice on the bottom, or a bracket with a squared on it on the bottom. That's all I'm meaning by that. Right, so let's do an example. Okay, let me just get this so it stops being quite so squint. Right, example 1. So find f of t. Right, so f of s equals 1 over s squared plus s to equal 6. Right, so it's asking you to find the original function. That's the Laplace transform, and it wants you to find the original function in t. Right, so you go to your table to start off with, right? And if I think about my function, it's got 3 terms on the bottom. It's got an s squared, an s, and a number. And if I look at the bottom of every single one of these, none of them have got 3 terms, right? So this table can't help us with that one at the moment. Right, but I look at the bottom and I try and factorise c dt. Right, is there a common factor there? Nope. Is it a difference of 2 squares? Nope. It must be a trinomial. Right, so I want to find numbers that add and multiply. Right, so we've done this all the way through maths, right, so that means 1s, right, in the same way it would mean 1x. So I'm adding to make positive 1 and I'm multiplying to make negative 6. So that means that one's positive and one's negative. So it's either 1 times 6 or 2 times 3. Right, remember one's negative and one's positive, so it must be negative 2 and plus 3. Okay, so just factorising. I'm hoping by now you can do that type of factorising without having to do all that working, but hey, whatever. So f of s equals 1 over, and it's s take away 2, s plus 3. Right, so that's the first step, and I said we need to factorise, and now we need to use partial fractions, right? So I'm just going to ignore the f just now, right? So we've got 1 over s equal to s plus 3. Right, and the first thing I notice, that bracket's not the same, right? If that bracket was the same, this wouldn't work. It would be the next type, type 1b, right? So remember, partial fractions, you make it a over the first bracket plus b over the second bracket. Just put brackets around it like that. Right, now we've done partial fractions loads of times, so we're just multiplying everything through by this thing here. So that means that 1 equals a multiplied by s plus 3 plus b multiplied by s take away 2. And remember, what you're thinking is, right, what's not on the bottom of this fraction? S plus 3. What's not on the bottom of this fraction? S plus 2. That tells you what you're multiplying through by, effectively. Right, then what we do is, just like we did in engineering 3, we choose the two values of s that make the bracket 0. Like, so when s equals negative 3, and you just swap all your s's for negative 3. So 1 equals a multiplied by 0 plus b negative 3 take away 2. Right. So 1 equals a plus b times negative 5. Okay. So, sorry, that should be 0. I'll just go with it. Right, it's 0. So 1 equals negative 5b. So b is negative 1/5. Right, so I've made the first bracket 0, now make the second bracket 0. So when s equals 2, 1 equals a 2 plus 3 plus b multiplied by 0. So I just take my equation that I got after my partial fractions and I swap all my s's for 2. That gets rid of the b term. So 1 equals 5. So a equals a 5th. Right. So I had 1 over s take away 2, s plus 3 equals a over s take away 2 plus b over s plus 3. Right, that's what I had when I started my partial fractions. Now I've worked out that a is a 5th and b is negative a 5th, so that means that really as 1 over 5 s take away 2 take away 1 over 5 s plus 3. Okay, because a was a 5th and b was negative 1/5. And remember what I said to you before, your 5's and s's are going to start looking the same. Try and come up with a way in which they don't. I'd try and make the top flat and then just try and, I don't know, put more straight lines in my 5's. Okay, so now I want to find the Laplace transform of that. Right, so I've got f of s equals 1 over 5 s take away 2 take away 1 over 5 s plus 3. So what I do is I go and I want to find the inverse transform. As I said, that's just L inverse right now. So really what I'm looking to find is, I can take out that fifth, like that. We could take out the fifth and the fifth and the negative, fifth and the fourth, list of things here. Right, so all I'm looking for is the inverse Laplace transform of that, and the inverse Laplace transform of that. So I go to my table, and I'm looking for something that's just got S and a number in the bottom. And I see that our S takeaway, or S plus a number, and I see that's that one there. So f of t is equal to a fifth, and that's just going to be e to the power of 2t, take away a fifth, e to the power of negative 3t. Okay, so that's that question done. I found the inverse Laplace transform. You can tell you found the inverse Laplace transform because you get f of t and all your s's are gone. All your s's have been replaced by t's. Right. Example 2. Right, now, what I'd like you to do, for anyone who's confident and feels like that wasn't too bad, I want you to go and try and do this one yourself before I go over it. So again, if you're not that confident, just keep watching. So if you feel confident you want to have a go at it yourself, then pause the video here. So that's f of s equals s plus 7 over s squared take away 3s plus 10. For everyone else, I'm going to go over this one. Right. So first thing we want to do is try and factorise the bottom. So because I know that as soon as you've got 3 terms on the bottom of a Laplace transform, you need to do factorising or completing the square or something. So I always try factorising first. So c dt, right, is there a common factor? There's s in the first 2 terms but not in the last term, so it's not that. It's 3 terms, so it's not a difference of 2 squares, so it must be a trinomial. Right, we've been doing trinomials for years and years and years, as I said before. So I'm adding to make negative 3, and multiplying to make, hold on. Okay, that was a mistake on my part. That should be t with 10. Sorry to anyone who has stressed themselves out trying to get that. That's, the question should be 10. Right. So negative 10. So same thing again. 1 positive, 1 negative. You've got 1 times 10. 2 times 5, it's not the 3 times 2, right, that's it. So it is plus 2 and negative 5. Like that there. Okay, so let's do our partial fractions. So s plus 7 all over s plus 2 s to the 5 is a over s plus 2 plus b over s take away 5, like that there. Now, multiply everything through by the bottom. Like that. So, then we've got to choose the two values of s and make our bracket 0. So when s equals 5, that's going to make this bracket here 0. So let's make everything 5. So 12 equals 8 times 0 plus b times 7. So 12, 7b, so b is 7/12. For these numbers, and in year 5 you can see that the numbers aren't as nice. Like we end up with a lot more kind of fractions rather than just whole numbers. Right then, when s equals, right, this fraction again, well what's going to make that bracket 0? Negative 2. So make every s in here a negative 2. So 5 equals negative 2, take away 5, so that's negative 7a plus 0. So a is negative 5 over 7. Okay. So that means we've got s plus 7 over s plus 2, s take away 5 is equal to negative 5 over 7 s plus 2 plus 7 over 12 s take away 5. Like that was my original function. That was f of s. So f of s is equal to negative 5 over 7 s plus 2 plus 7 over 12 s take away 5. So I want to inverse Laplace transform that. So that means I can take out that negative 5 over 7. That just makes it inverse Laplace transform of 1 over s plus 2. And I can take out the 7 over 12. That just makes it inverse Laplace transform of 1 over s take away 5. So that there just becomes f of t. So that's going to give you negative 5 over 7, and this here just becomes e to the power of negative 2t, so from the table. And that becomes e to the power of 5t from the table. So my final answer is that the inverse Laplace transform of that is negative 5 over 7 e to the power of negative 2t plus 7 over 12 e to the power of 5t. Okay. So if you want to try one more question, then I'm going to have a little look in the book. If you look at question 1 on page 29, there's a question. It's a lot easier than that one, I would say. but have a look at it and see how you go. Right, the reason that's easier is it's already been factorised for you, so there's nothing for you to do at the start. You just crack on straight into partial fractions. Right. We've got type 1b. Okay, so this is when you can factorise the bottom, but there is a repeated linear factor. And as I said, i.e. a repeated bracket or a bracket with a square in it. And that's how you can tell if something's got a repeated factor, right? So type 1b is when you can factorise the bottom of the function you're looking to inverse transform, but there is a repeated bracket or a repeated linear factor in the bottom of your function. Right, so example 1. So f of s right. So a couple of things I've got to notice about this. I go to my Laplace transform table and there is absolutely nothing in this table that looks like the bottom of that function. The bottom of that function has got loads of different stuff in it. So I know I'm going to have to split it up. Right? Now, see, because I see I've got two brackets. As soon as I know I've got two or more brackets, I know I'm going to have to use partial fractions. But this is a quadratic with three terms in it. So I've got to try and see if I can factorise that first. Right, so I'll look and see if I can do CDT on that bracket. So again, there's no common factor there. There's three terms, it's not a difference of two squares. So it must be a trinomial. Right, so adding to make plus 2, multiplying to make negative 3, 1 positive, 1 negative, 1 times 3 or 1 times 3. It's the only way you can make 3 through multiplying. So it's going to be negative 1 and plus 3. Right, now I've got three things in the bottom of a fraction, but that's fine. We did partial fractions and integration in engineering 3 with 3 brackets on the bottom. But the problem I have is I've got a repeated bracket. I've got the same bracket twice. So remember, that means we've first got to write it as like that. Now, that means our partial fractions are slightly different. So again, ignore the fs just now and we'll just go into partial fractions. So s squared plus 9s plus 2 over s equals 1 squared s plus 3. Right, so remember when you've got a repeated factor, you've got to put in the original factor and the square factor, right? So I'm going to have a over s take away 1 and b over s take away 1 squared. And those are both just for that bracket there. Right, that's just for that part of our function there. Plus c over s plus 3. Now, as I said to you before, if that was a cubed, you would have s take away 1, s take away 1 squared, and s take away 1 cubed. It's just the way to make partial fractions work. Try and adjust it because it was getting a wee bit blurry there. Right. So, we're going to multiply everything by the bottom here. Right? So, we've got s take away 1 on the bottom here, so that means I'm missing an s take away 1 and an s plus 3. Right? I've got s take away 1 squared on the bottom, so that means I'm missing an s plus 3. And I've got s plus 3 on the bottom, so that means I'm missing an s take away 1 squared. Like that. Okay, now remembering when you've got the repeated linear factor, exact same process, you find whatever makes that first bracket 0, we find whatever makes the second bracket 0, and then you just choose a random value for s, normally 0. Right. So when s equals, well, that would be 1. So we substitute 1 in out in case they're in here, so that's 1 squared plus 9 times 1 plus 2 equals 8, 0, 1 plus 3 plus b, 1 plus 3 plus c times 0 squared. Right, because remember the whole point of making S1 is to make those brackets 0. Okay, so 1 squared plus 9 plus 2 is 12. Well, that's 0. That's 4, so that's 4b. And that's 0 there. So 0 and 0. So that means that b is 3. Seems like a nice example so far. Right. Let's have a look at the next bit. So I need to choose another. Well, that bracket is going to be 0 if I choose s to be negative 3. So right. So that's going to be a negative 4 times 0 plus b times 0 plus c of the negative 4 squared. Okay, so I'm going to get my calculator out so I don't make any mistakes, because I always do. So that gives me negative 16. That gives me 0, that gives me 0, that gives me 16c. So that tells me it's c is negative 1. So I've got a value of a. I've got a value of b, I've got a value of c, I need to find the value of a. So I go back to my equation that I find stuff from, which is this one here. There's no other brackets that I can make 0. So in that case, you choose s to be 1. Sorry, s to be 0. Okay, so you just put 0 in place of all your s's. So that's 0 squared 9 multiplied by 0 plus 2 equals a like that. Now, I find if I'm putting in 0 I need to write it out because I always make a mistake with negative numbers, so have we watch for that? So that's 2 equals a of negative 1 3 plus 3b plus c times 1. So that's 2 equals negative 3a plus 3b, take away c. Right, but I already know that b is 3 and c is negative 1. So 2 equals negative 3a plus 3 times 3, take away negative 1. Sorry, plus c that is. Plus negative 1. Oops. Thank you. So you've got negative 3a plus 3b plus c. Then you substitute in your 3 and your negative 1. So 2 equals negative 3a plus 8. So you move that across, so negative 6 equals negative 3a. So a is 2. Okay, so s squared plus 9s plus 2 all over s equals 1 squared s plus 3 can be written as 2 over s equals 1 plus 3 over s equals 1 squared take away 1 over s plus 3. Right, so I've just done my partial fractions now, so that's fs. Can now be written as that. Okay, and now I need to inverse Laplace transform these things. Okay? And I'm just going to take those constants out like I've been doing throughout this. So that's 2 times inverse Laplace transform of 1 over s take away 1 plus 3 plus inverse Laplace transform of 1, sorry, take it, subtract s plus 3, like that. Okay, sorry I couldn't fit that all in one line. So that means it's 2 times inverse Laplace transform of 1 over s take away 1 plus 3 times inverse Laplace transform of 1 over s take away 1 squared take away the inverse Laplace transform of 1 over s plus 3. Suppose I could have brackets around these earlier on, wouldn't make a difference either way. Right, now let's have a look at our table. Now, I've got 2 which just look like that, right? So it's just going to be an exponential. But in my other one, I've got s take away 1 squared. So I've got s take away a plus a number and a bracket squared. That isn't like any of the ones I've got there. which is a bit of a blow. But I can make that there look like one of my transforms if that S take away 1 wasn't S take away 1 and instead was just S, right? So f of t would be 2 times the inverse Laplace transform 1 over S take away 1 plus 3 times the inverse Laplace transform now what I need to get is 1 over S squared, right? Which means I want S take away 1 to become S. Take away the inverse Laplace transform. Okay, now I can find the Laplace transform of everything there. Okay. So that's 2 e to the power of 1t plus 3 times, I'm going to keep this in a square bracket just now, and I felt 1 over S squared is just t. And that there, sorry, move that there, right, so if I do the inverse Laplace transform, I just get e to the power of t. Now, if I do the inverse Laplace transform of this thing here, I get just t. Now, I've got this thing here, but I'm going to sort that out in a minute. And if I do the inverse Laplace transform of that, I get that. Now, what I'm looking to do is use this thing here, right? Now, remembering the other way round just meant that went from an exponential into looking like that. So when I go the other way, this thing here just becomes an exponential. However that number there is, goes up here. So that's -1, so that becomes 1 here. And that's me finished my inverse Laplace transform. So that is in there. Inverse first shift theorem. Okay. Okay, after you've had a look at that, you can then try page 29, question number 3. Okay, now questions 2 in fact you could do question 3 and you could do question 4, because 3 and 4 should in theory be okay. Yeah, should be fine. Right, now questions 2, 5 and 6 on that page involve an irreducible quadratic factor, and that's what we are going to be looking at tomorrow. Okay, so please have a go at those questions. The answers are obviously at the back of the booklet, and I will update you with a new lecture tomorrow.